provided with the solution of Fe2 plus and Fe3 plus prepared in 0.05 molar sulfuric acid. It's already there on your table there. Right, so you have been provided 0.05 molar Fe2 plus and 0.05 molar of Fe3 plus prepared in sulfuric acid. You don't prepare that in water because of the low solubility of iron in water. We add acid so that the Fe gets highly solubilized. That's where sulfuric acid comes in. In today's class, we have prepared the two solutions for you. In the lab test, we might not be preparing the solution for you. So the two are salts that have been used to prepare these two are there on the board. You should be able to do the calculation and you should be able to know how to prepare in 0.05 molar. Can you do that? We gave time to do that or you not gave? Okay, you do that because the lab itself is not that long. You do it well, it should be fast. So that, let's get the MR for this two. Oh, yeah, you find the MR of that. The MR, find the MR of the two. You should know which one is Fe2 plus and which one is Fe3 plus. I will not tell you that. Using CH2O4 as your base now, to understanding how to find the oxidation state of iron, you should be able to know which salt is the ferric form and which one is the ferrous form. You should be able to calculate and prepare 0.05 molar solution of this. So how will you prepare 0.05 molar of this and this? Remember, whenever you prepare an iron solution, we never prepare it in water. It's always going to be added with acid. Even though you add some water to it, right? What will happen is you will add some pump acid so that the iron solubilizes. In this case, your iron is prepared in a dilute sulfuric acid, right? So that the whole iron process is in the solubilized form. Put it in water, it won't solubilize. And there is no point of doing your experiment. So you should be able to do that. Prepare that solution in 100 ml. 100 ml. How will you prepare these two in 100 ml? That's the concentration of that particular two salts.
Middle. So the first one. So 1.96 gram.
What's the
first one. MR 392 for the first one.
and the other one?
So this is the first one is correct.
Calculate the MR. Calculate the MR of both. Then determine which one is your Fe2 plus and which one is your Fe3 plus using your CH2O4 knowledge. And then we go off to the lab this week. Why I am telling you this? Because in the lab test, this is two parts of the experiment, part A and part B. You may be then asked to do part A or part B. So the remaining part is where we provide you with the solution. So it's all to prepare and start. You should be able to tell me which one is what.
Second one.
Which one is ferric and which one is ferrous?
I have to test it now.
Tell me, how will you go about preparing the two? Okay, tell me which one is which. But out of the two salts, which one is the ferric and which one is the ferrous? Which one is the ferric and which one is the ferrous? Which one is Fe2 plus, which one is Fe3 plus? 204, you done this. And all of you doing 204, I know that.
Madam, the overall charge
Is zero.
is 0.
Yeah.
So each has certain charge. In the Fe we have to find it's the unknown x. So we find the x.
So which one, after finding the x, which one is Fe2 plus and which one is Fe3 plus? Because in the test I will give you this, I will give you the two salts. You figure out which one is Fe2 plus, Fe3 plus.
4,
If we have done it, you know.
2, Fe.
The second one is fair.
I think or you know? No think here. No think.
Wait, the charge for nitrogen -2.
Ammonium ion. It's
Oh, it's,
ammonium. It's ammonium.
It's negative.
It's minus
Plus.
+1.
Ammonium ion is +1.
Yeah.
1, 2,
Now tell me.
2 plus
The second one is
sulfate -2.
Fe3 plus.
and the first one is empty.
SO4
Others,
-2.
which one?
4 plus
Which one is Fe2 plus and which one is Fe3 plus?
12 plus -6 to 0.
It means your 204 is very weak. Okay, while you're calculating, tell me how you're going to prepare that concentration in 100 ml. What will be the step?
Measure for the mass first.
How do you find the mass?
Find the moles.
Using the
Moles is equal to CV.
Okay, first of all, it's given you the concentration.
yeah.
You know the concentration,
Yeah.
you know the volume.
Yeah.
You can find the moles.
Yeah.
Yes? Remember that 100 ml goes into liters.
Yeah.
Very important. Goes into liters.
Get
So
the
0.5 times 0.05 times 0.1 will
Yeah.
give you the number of moles. That number of moles multiplied by the MR of the salt should be able to give you the mass that you need to weigh to make up that particular concentration.
yes.
Alright?
Yes.
Now tell me which one is Fe2 plus and which one is Fe2 plus.
First one,
is
Fe2 plus.
The second
F1, the first one is Fe2 plus
Yes.
and the second one is Fe3 plus.
plus.
Given in the lab test, please don't look at my face. Yeah? Don't look at my face because there was one person who looked at my face for 4 hours.
Oh,
I didn't do anything. I said, there, you figure it out. Once the time was over, I call it to the paper. So please, you should know how to attempt it. Despite being given the solution today, you should know how to do it.
You.
All clear?
You.
Now this is going to be your potentiometric titration and your redox potential. So this is how your setup is going to look like. You'll have your magnetic bar stirrer here. That's your magnetic stirrer. Remember, it's magnetic stirrer.
You.
No heating, right? So you have your beaker here, and you have your burette here. That's where your burette will be clamped. That's your burette. We'll have a stirrer here that will keep on stirring. And in here, we'll have your, one of the solutions will be up here. Whichever one will be up here. Now your electrode, this is your electrode. This one. This is your electrode. It will go into the multimeter and you will have the standard Kelly-Moll electrode on the other one to complete the circuit. Right? Now if you look at the electrode for this one here, the electrode is the platinum wire. The platinum wire. Not the whole electrode is one. inside just the platinum wire. So the whole reduction is happening on the platinum wire. You don't dip the whole thing in the solution. Otherwise you create a different environment for it. And you get all sorts of readings. So when you are going to assemble your setup, make sure it has to be done in such a way that only the tip of the platinum wire is dipped in the solution, and this will be clamped, right? This is basically your setup. Only the platinum wire is going to be dipped in the solution. Put it up in such a way that it's only the platinum wire that is dipped, not the whole electric system. And then the SCE will be also dipped there. You have your SCE here. This will be your SCE. This will be your platinum. And this will be connected to your multimeter here. Right? Now, important thing is you will do the first reading, which will be 0 mils without the addition of the plus. You go in, take the reading. When you start adding your solution, you draw through the mils that you require to deliver from the burette. To give it a good mix, you stop the stirrer. Don't have the stirrer on and then keep on trying to record the reading. It's always already in the dynamic movement. Your readings will keep on fluctuating. Give it a good mix, stop the stirrer, and then take your reading. If you do that carefully, you shouldn't have any problem. You expect your potential to increase upon the addition of your volume from the burette. You should see an increase in your voltage. That's how you should be able to plot your linear curve. Using the nest equation, CH101. Nest equation is coming back again. Remember, nest equation is always used when we are not at the standard conditions, non-standard conditions. Concentration is not 1 molar, your atmospheric is okay. So here, we are going to use the nest equation. That's for the first part. Once you finish the first part, we are going to do the potentiometric titration now. That means you will get your end-point using the potentiometer. That means the voltmeter should be able to give you the reading. So you should be able to get a value like this. This is your sigmoid curve you're going to plot. Right? Then you can know the E naught value here, half, here, plus half. You should be able to get your midpoint, should be your endpoint. Now, in your procedure for the second part, which is the potentiometric one, you pipette out whatever you have to do. It says here pipette out, dilute. Now, the amount of water you're going to add, pipette into and insert the and dilute with water until the electrodes are covered. You keep count of the amount of water you are going to add. Right? So, if you added 10 mils and then you added about 100 ml, when you come back to repeat the part where you have to do part 4, you should know I have to add 10, 100 ml, whatever ml I have to add. Otherwise your potential readings is going to change. So do that and you do the titration till you get to 22. So what you will see is when you do second part, upon the addition of your CE, you will see that the readings will increase and there will be a sudden jump, a big change in the voltage reading. So the first part of your part, second part basically is this part here. You will get this part here and then the jump that happens there. Then you come and fill in the dot for the next part, that is the middle part. That is where you are going to repeat part 4. So you go back. Say for example, when you are doing your readings, so say about 0 mil, 2 mil, 4 mil, 6 mil, 8 mil. By the time you came to the 8 mil, you had say about 450, 440, 420, something like that was your voltage readings. By the time you came to the 10th mil, it jumped to say 900. See, that's a big jump. So we will go and try and see how the voltage changed during that addition. So here, where it says then you go and repeat, that means you go back 10 mil, 100 ml, you add directly 8 mil from the burette, and then what you are going to do is going to do 0.2 mil addition instead of 0.1 ml addition. So you will then actually expand that region of your titration curve, of your titration table. So it will be like 8.2, 8.4, 8.6, 8.8, then you get 9, 9.2, 9.4, up till you go up to the 10 mil. So basically we are trying to expand this part so that we can extrapolate this graph. Okay, so that's basically what it means for part 2. Part 4, part 2 of part 4. Right, when it says repeat, and you do repeat the titration taking readings only near the equivalence point. Example 0.1 cm cube for each 1 ml on either side. We'll see where the jump happens for you guys. We'll sell, but instead of doing 0.1, we'll go to 0.2 mil addition. 0.2 mil addition should give you good readings, and you should be able to pull off your graph. All clear? This one is a very simple lab, but the important thing is you just have to be mindful that your electrode is the one that is going to be sitting, the platinum one, in the solution. So be mindful that that is the only tip that is in the solution, nothing else. Not the whole glass setup. Okay? To do that carefully, you should be able to get everything done for it. Right, I believe everyone is paid. Anyone without a pair? Yeah, you work with her. Come. Yeah, you have your electrodes. Do they get the card for the bar? Yeah. So bring your ID card. I'll issue you the bar. So you need the steering wheel. Yeah. Yeah, you bring whatever you have. Get going.
Do you have anything?
As long as you remember what you gave me. No, do first set up the whole thing, then come and get the bar for me. First set up everything. Set up the whole setup. Do the whole setup.